so this class we're going to get into 10.2, properties of linear functions. The MD60 is just a part of my notes. I'm about to switch to some other notes, but it's properties of linear functions. What are functions though? Intercepts, that's right. All right, so this is where we're start looking at our intercepts. All right, somebody has a question. Wi-Fi in the building. Isn't working well. It said my connection can't display videos. Okay, well, it's not a problem. If you can't see it right now, I'll shoot a video out to you shortly. I do understand everybody having a little bit of issues as far as connectivity is concerned. So I completely understand. Thanks for letting me know. All right, so in 10.2, we start off by talking about intercepts. Make sure they had internet shut down. Oh wow, our internet shut down. That's crazy. I can't see or hear anything. Okay. Can other people hear me before I keep going? I don't want to keep going. And I'm just talking to myself. Can somebody hear me and see the video? Okay. All right, cool. So, like I said, okay, great. The connection is really bad on campus. Okay, got it. Okay, so let me type in there again. Let's see. So this is just for those who cannot hear me. Just cutting your sound off more than that. Okay. All right, so let's go ahead and knock this out. And they said in the chat, I'll make sure I shoot this video out sometime between today and tomorrow. All right, so your intercepts, your x-intercept is where the graph intercepts or crosses the x-axis. Your y-intercept is where the graph intercepts or crosses the y-axis. Characteristic for all x-intercepts is that y is always 0. Characteristic for all y-intercepts is that x is always 0. All right. All right, so let's go ahead and erase this stuff so we can walk through it. All right, so if we want to graph using our intercepts, let's say if I have 2x plus 3y equal to 12. Characteristic, it doesn't matter which one you decide to find first, whether it's your x-intercept or y-intercept. I always tend to find my x-intercept first. But if I'm going to find my x-intercept, the first thing we recognize that the characteristic of all x-intercepts is that y is equal to 0. So you let y be equal to 0 and plug that 0 into your equation. So that's 2x plus 3 times 0 equal to 12. 3 times 0 is 0. That gives you 2x equal to 12. Now divide both sides by that 2, and x is equal to 6. So it means your ordered pair 6, 0. Remember, x comes first, then y in your ordered pair. All right, for the next one, same thing, but in reverse. Look for our y-intercept, so we're going to let x be equal to 0. Plug in 0 for x. 2 times 0, get 0. So that leaves you with 3y equal to 12. Divide by 3 is equal to 4. So this order pair would be 0, 4. All right, questions before we use that information to graph? All right, so you go to the graph, your ordered pair 6, 0, you go to the right 6, nowhere for x. Go back to your origin, go nowhere for x, put up 4. And draw your line through both points. Questions? Questions on that? All right, so let's use that same concept in the application. So it says after a parachute is deployed, a function that models the height of a parachute is above the ground is f of t equal to negative 10t plus 2800, where f of t is in feet. F of t in feet, of the parachute is t seconds. After the parachute is deployed, find the intercepts. Explain what they mean in context. So I'll give you a chance to write that out. So we want to find the intercepts, and then after that we will explain what they mean. So it tells us that t is for seconds, f of t is feet. Don't forget we talked about interval notation, not interval notation, function notation. So that f of t is going to be y, and the value that we plug in would be the same thing as x. So we can look at it in that way. What I'm plugging in is my domain, or in other words, what I'm plugging in is my x. What I get out is my y. Function notation says that f of t is my y. So if I start off by letting t be equal to 0, plug t, not plug t, but plug 0 into the function, that's negative 10 times 0 plus 2800. Of course, 10 times 0 is 0. That would be 2800. All right. So at t equals 0 seconds, the parachutist is 2,800 feet in the air. So don't forget what t represents. T is t seconds after the parachute is deployed. So it's not just NVO seconds. It's how many seconds after he or she opens up the parachute. So at t equal to 0, those are passed yet. So the parachutist is 2,800 feet in the air. All right, any questions on that? So now we'll let f of t be equal to 0. All right, so that'll be 0 equal to negative 10t plus 2,800. So to solve for t, subtract 2,800 from both sides. So that'll leave you with negative 2,800 equal to negative 10t. So then we'll divide by negative 10. Negative 10 cancels on the right, leaving us with t equal to 280 seconds. So f of t is your feet. So when your feet is at 0, so remember we were talking about last part of this problem, 2,800 feet in the air. So if your feet is at 0, that means the parachutist has touched the ground. So it took the parachutist 280 seconds to touch the ground. F of t was how many feet in the air? All right, questions. All right, what's that? Yes, Mr. Harris.
So when you took the 2,800 and moved it
Mm-hmm.
to the other side, when you did what do you find the least common denominator, or like are you dividing them two together?
Okay, so now, I just want to make sure we're in the same spot. So you're talking about when I had 0 equal to negative 10t plus 2,800.
Yes, sir.
So, yep. All right, let me go back to the notes. So we were here. So now your goal, in order to solve for t, your goal is to get t by itself. So you need to undo what's being done to t. So I have negative 10 times t plus 2,800. So what's going to move the plus 2,800 is a minus of the 2,800. So plus and negative 2,800 will cancel. And then whatever you do to one side of your equal sign, you have to do to the other side. So if I subtract 2,800 on the right side, you have to subtract 2,800 on the left side. So that's how we get here, because we subtracted 2,800 from both sides. So now we have negative 2,800 equal to negative 10t. See, so now once again, your goal is still to get t by itself. So if I'm having 10 times t, now I need to divide by that negative 10t. And then the t's, I mean not the t's, but the 10's cancel. And then you're left with the 280.
I got it now. I see. Thank you.
Yep, no problem. All right, anything else before we go to the next part? All right, so the next part of this is your slopes. All right, so your slopes will be represented by M, and that'll be y2 minus y1 over x2 minus x1. Or you can do y1 minus y2 over x1 minus x2. You just have to make sure that when you do this, you stay consistent. So in other words, if you use y2 first on top, use x2 first down bottom. Or if you decide to use y1 first on top, you use x1 first on bottom. Then we also have the relationship of rise over run, which will help us when we go to graph. All right, x1, y1 would be 0.1, x2, y2 is 0.2, and they are just going to represent any 2 points on the line. Any 2 points on the line will help you to calculate the slope for that line. And your slope is just the incline of the line, the steepness of that line, like the slope of a mountain, slope of a roof. All right, so if we had 2 points, they ask us to find the slope at the point -2, -4, and then 3, -5. First, you will decide which one you're going to call point 1 and which one you're going to call point 2. So I decided to call -2, -4, point 1, 3, -5, point 2. So I'm going to do it both ways first to make sure we're okay, and to show you that either way you'll get the same result, but you only have to do it, one way when you go throughout doing it on your own. So the first way, y2 minus y1 over x2 minus x1. Y2 is -5, y1 is -4. Make sure you don't lose a negative. There's a minus sign in the formula, and you're plugging in -4. So make sure you're careful with that. Then x2 is 3, and x1 is -2. All right, so be careful. Negative to a negative is positive. So it's -5 plus 4, 3 plus 2. So on top, there's -1. On bottom, that is 5. So it's -1/5. Don't have to convert it to a decimal or anything like that. Leave it in fractional form. But you do have to make sure it's reduced as much as possible. Of course, they want the most simplified answer possible. So we decide to go the other way with it, do y1 minus y2 over x1 minus x2. Just switching around your numbers. Y1 is -4 minus y2, which is -5. Then x1 is -2. That's a -2. Y1 is -4 minus -5 for y2. Then for x1 is -2 minus x2, which is 3. Once again, we have a negative to a negative, which is positive. So that's -4 plus 5, that'll give you a 1. And then -2 minus 3 is -5. So either way, you're going to get -1/5. Just have to be consistent. Once again, if you do y2 first on top, x2 first down bottom, or y1 first and x1 first. All right, questions. All right, let's do one more just to make sure we're okay. All right, so 5 and -6, 8 and 3. First point, column 5, -6. Second point, 8, 3. So y2 minus y1 over x2 minus x1. Y2 is 3. Y1 is -6. X2 is 8. X1, 3. Once again, -2, negative turns positive. Oh, I put a 3 there. It should be a 5. Sorry about that. Should be 8 minus 5. X1 was 5. So 8 minus 5 is 3. And 9 over 3 is 3. So my slope is 3 here. All right. Any questions? All right. All right. So the basic behaviors of your slopes. Reading your graph from left to right or following your graph from left to right. If it's going up, or in other words, increasing, that means your slope is positive. If it's going down, your slope is negative. Horizontal line means that your slope is, excuse me, is 0. And then a vertical line means that your slope is undefined. All right. I don't think y'all need that. All right. So here we go here. So let's look at graphing using our slopes. So like I mentioned, when we first started talking about your graphs, first started talking about your slopes, that your slope is going to be equal to rise over run as well. Your rise is going to be up or down. Your right will be right or left. Your run will be right or left. So your slope is actually going to be instructions on where to go and how to go in order to generate another point or multiple points on your line. So your positive moves will be up and right. Your negative moves will be down and left. All right. So for an example, if I have m equal to 3 over 4, that's a positive 3 over a positive 4. So that means you would go up 3 and right 4. All right. If I have, this other thing. If I have a negative 5 over 7, that negative does not go to both terms or both numbers. It goes to one, either top or bottom, because remember, a negative over negative is positive. So that negative cannot go to the top and bottom. It goes to either or. So I always help you to just give to the top number. If you do that, that's negative 5 or over positive 7. So that means I would go down 5, right 7. So don't, oh, erase my mistake. So that just means you would go down 5, right 7, put you right here. But if you decide to put the negative to the denominator, that means you would have a positive 5 over a negative 7. So you would go up 5, left 7, which will still give you the same line. So either way, you will get the same line. Just remember that that negative sign cannot go to both numbers. It goes to either or. And then you will make your moves accordingly. All right. Before we use this information to graph, any questions? All right, so here we have our slope-intercept form. Y is equal to mx plus b, wherein the m is your slope, your b is your y-intercept. So notice the form of this equation. You have your y is by itself. So whenever you take your linear equation and solve it for y, and simplify as much as possible, of course, it's in slope-intercept form. So if I have y equal to 2/3 x plus 1, my slope, the number that's sitting in front of x, is 2/3. My y-intercept is 1. And so I try to point out the fact that we're talking about what's in front of x being our slope, because a lot of times, for some reason, people like to keep the x attached to it. And so if somebody asks you what was the slope, they would write 2/3 x. But your slope, it does not have a variable attached to it. Your slope is just a number. So your slope would be 2/3, not 2/3 x. All right. So questions. And then here's the same type of situation. Y equal to negative 8 over 13, x minus 5. So your slope is negative 8 over 13, and then your slope, your y-intercept, is negative 5. Any questions? All right, so directions on how to use that slope to graph. First, you'll plot the y-intercept. Then you'll generate another point from the y-intercept with the slope. So make sure, and you'll see in a second, that you start from the y-intercept, not from the origin. When you use the slope information, your slope is not a point, so we don't go back to the origin, we go to the y-intercept. All right, so if we have y equal to 2/3 x minus 1, my slope is 2/3. My y-intercept is -1. Now don't forget, we already mentioned that the characteristic of all y-intercepts is that x is equal to 0. So when I look at the coordinates of my y-intercept, they gave me -1. But since they told me it was y-intercept or was a y-intercept, the coordinates of that would be 0, -1. Then for my slope, I have +2 over +3. So that means I will go up 2, right 3. All right. So questions before we graph? All right. So you graph your y-intercept first. So you go to 0 and then go down 1. So that's my point right here. 0, -1. Now from your y-intercept, you go up 2 and right 3. That's my line. And that will be your line. And if I wanted, I can keep going up 2, right 3, up 2, right 3. It'll continue to generate points on the line. All right. Any questions? All right. So let's do it again. So if I have y equal to -1/4 x plus 3, my slope is -1/4. So that means I go down 1, right 4. So that's a -1 over a +4. And my y-intercept is 3. So my coordinates will be 0, 3. All right. Any questions? So you grab 0, 3. Go nowhere for x, but then up 3. That's right here. Now from your y-intercept, you go down 1 and then right 4. That'll be right here. Those are your 2 points. All right. Questions? Any questions? All right, so let's get started with 10.3. Starts off with points. All right, so we're starting here with the point slope formula. Y minus y1 equal to m times x minus x1. And m is our slope. x1, y1 is any point on the line. All right. All right, so find the equation of the line that passes through 1, -3 and has a slope of -2. All right, so that means m is equal to -2, and then x1, y1 is 1, -3. So if we look at the formula, so notice we're plugging in for these three values right here. Make sure you don't lose a negative in your substitution. Y1 is -3, so that's y minus -3. M is -2, and plug in +1 for x1. +3, distribute that -2. So that'd be -2x plus 2. And we can finish it off by subtracting 3 from both sides. So y is equal to -2x minus 1. All right. Questions? Any questions? Someone said some students have been kicked out due to internet not working. I believe probably they either were kicked out or they decided to tap out because they couldn't hear or something like that. Yeah, probably. All right, so I'll give you guys a chance to write this out, but based on data from Kelly Blue Book, the value of a car decreases approximately, I just did APP for approximately $250 a month or per month. If the value of the car 2 years after purchase was $14,000, find a linear function that models the value after X months of ownership. Use this function to find the value after 3 years. All right. So first thing we want to do is establish our variables, X and Y. X, they told us, X months of ownership. Y is going to be the value. And so Y will be the value after X months of ownership. So if you notice what this was a setup from the last problem that we had our slope and we had our 2 points. We had our 1 point. So whenever you look at your rate, they're going to give you a rate most of the time. If not, then you have to find it. That rate is your slope. So $250 per month is our slope. Then we need X1, Y1. And that would be 2 years and 14,000. So remember, X is months of ownership. And then Y was the value after X months. And so the reason why we have to make sure we read this properly is because we're talking about months here, but they gave it to us in years. So we do need to convert that before we actually use it in our problem. So they give it to us in years. We need to convert that to months. And there's 12 months in a year. So we should have 24 and 1400. All right. So before we go any further, make sure we're okay. So the formula, y minus y equal to m times x minus x1. Y1 is 1400. M is 250. X1 is 24. Distribute the 250. Y minus 1400, 250x, 250 times 24, I believe it's 600, 6,000. Let's see. Ooh, I think I left off one thing. This right here. I forgot one thing. Don't forget the car decreases by $250 a month. So that means my slope should be negative. Sorry about that point. So make sure we change that. Your slope is negative because of decreasing. Just all right. So that makes more sense. I was just thinking why the calculation wasn't coming out right. So, yep, your slope is negative because it decreases. Now, if it increased, you know, at 250 a month, then it would have been positive 250. All right. So now, when I add 1400, and I messed up again. I left off that zero. I'm gonna get it right. It's still 8 o'clock in the morning. All right. So that should be 14,000. I left off that zero. All right. So 14,000s will cancel. Leave me with y on the left. Negative 250x plus 20,000. So on the right. Yep. So make sure you'll do like I did, leaving off zeros. You will get the wrong answer. All right. Questions before we do the next part? I think I see a hand. Yep, Mr. Harris.
You said don't leave off any zeros.
Oh yeah, that was my mistake. I left off. Let me go back to the notes. Yeah, I left off. Right here in the problem is 14,000. I had made a mistake and wrote 1,400 right here. So I was just saying, make sure that you, write down whatever number they gave you. That's all. Yeah.
Gotcha.
Mhm. All right, so we're almost finished. This problem says use this function to find the value after 3 years. So we want to find the value after 3 years. Don't forget, we have to convert it to months in order to use this equation. So multiply the 3 by 12, get 36 months. Once you have that, you can go ahead and plug it in to the equation. 4x, so that's negative 250 times 36 plus 20,000. And I can go ahead and multiply that out. So that's negative 9,000 plus 20,000. Car would be worth $11,000 after 3 years. All right, the next type of problem in this section is only two. One, when you get the first one, like we did last two scenarios, you would get a slope and a point, or you can just get 2 points. So if you have 2 points, first thing we need to do is take the points, take the 2 points, and find the slope. So let's establish what our points are as far as labeling. 6 and negative, I can call that x1, y1. 3, 2, x2, y2. So we need a slope in order to find this equation, so we have to find the slope first. So it's y2 minus y1 over x2 minus x1. Y2 is 2, x1 is negative 4. Well, I say x1. Y2 is 2, y1 is negative 4, then x2 is 3, and then we have 6 for x1. Once again, negative to a negative turns positive. So the 6 on top. On bottom, 3 minus 6 is negative 3. So my slope is negative 2. So next, we're going to use our point slope formula, which is what we started off talking about in this section. So we use either one of those points. It doesn't matter which one we use. I'm just going to go ahead and use the one I've already called x1, y1. Once again, it doesn't matter though. The line runs through both points. So either way, you should still get the same line. So y minus y1 equal to m times x minus x1. Y1 is negative 4. M is negative 2. And x1 is 6. Y plus 4. Distribute the negative 2. So it's negative 2x plus 12. Finish it off by subtracting 4. So it's negative 2x plus 8. All right. Questions before we look at this last example? All right, sodium thiosulfate is used by photographers to develop some types of film. The table gives the number of grams of sodium thiosulfate that will dissolve in 100 milliliters of water at various temperatures. All right, so they gave a whole table, but then in the directions, and I just shortened up a lot of this stuff so we can just go ahead and get to the problem. In the directions, they told us to use the points 250 and 130, 100, 230. So this is how it will be set up with multiple values, and then they told us to use 250 and 100, 230. So instead of writing out that whole chart, just went ahead and put in the values that we needed, but also showing you the categories on the left and right. So our X is the degrees in Celsius, and our Y is the grams that would be dissolved at that temperature. All right, so the question is, how many grams of thiosulfate does the model predict will dissolve in 100 milliliters of water when the temperature is 70 degrees Celsius? All right, so they gave us 2 points, 2050 and 100, 230. So we'll use those 2 points to find our slope, then use a slope in one of those points to find our equation. And then, just like we did in not the last example, but the example before, we can plug 70 into the equation and then see or get our answer. All right, so I'm calling it 2050 x1 y1, then 100 230 x2 y2. All right, my slope is going to be y2 minus y1, x2 minus x1. Y2 is 230, Y1 is 50, X2 is 100, X1 is 20. So, because of the nature of this problem, they went ahead and I'll write it down. converted that to 225. So now my slope is 225. And just like before, you can use either point. I'm just going to go ahead and use the one that I've already labeled, x1, y1. Formula, y minus y1 equal to m times x minus x1. So the y minus 50 225 x minus 20 distribute that 225. So y minus 50 equal 225x minus 45. Now to finish it off, we will add 50 to both sides. Y is equal to 225x plus 5. All right, so now to finish it off, we let x be equal to 70. But the temperature is 70. So we want to know how much would dissolve in 70 degrees Celsius. So plug 70 in for x. So that's 157.5 plus 5, 162.5. All right. So that's how many grams would dissolve in 70 degrees Celsius in 100 milliliters of water at 70 degrees Celsius. So, all right, so questions before we close out today? Everybody okay? Everybody all right? That was 10-3. So as always, make sure you guys try the stuff out, see if you get stuck on anything. If I need to meet with anybody outside of class, make sure you shoot me an email. I can do that. Nothing, just all about office hours, matching up our times, matching up our free time, and we will go from there. I do that with, I've done that in the past. So make sure that if you need help, individual help, that you shoot me that email so we can go ahead and set that up. Outside of that, if I'm good, I mean, if you guys are good, I'm good. Have a great day, and I will see you on Thursday.